Hello everyone. So today I will be solving a LeetCode medium problem, a gas station. So the problem states that we are given n gas stations in a circular route, and where the amount of gas at the ith station is denoted by this array gas of I, and we have the car, means the car has unlimited gas tank capacity, and we have a cost array which will denote the amount of gas required to travel from ith station to its next or I plus 1th station. And since like the array means the route is in form of a circular route, so for example if we have a route from 0 to n minus 1, so for n minus 1 the next station will be this 0th station. This is what we mean by circular route. So we are given a cost array which denotes like the cost required to move from ith station to I plus 1th station, and gas is the gas, means the amount of gas available at this station. Okay, now we need to return the start gas station's starting index such that we can travel around the circuit. So we need to find some index I such that we are able to go through all the gas stations and come back to this gas station, right, in a circular fashion, such that we were not able to, means we did not encounter a condition where our gas we ran out of gas. Okay, so we need to find a starting index such that we can travel around the circuit once in clockwise direction, and if it is not possible then we simply return minus 1. Okay, so for example if we have the input as this, so we have n stations, five stations here, 0 1 2 3 4. Now the gas available here was 1 and cost to go to next station was 3. Okay, so if we pick 0 as the starting point, we'll see like the gas available is 1 but the cost required is 3. Okay, so which is negative, means the net difference of them, the gas available and the cost required, is negative, since we cannot start from 0 because we'll never be able to reach this station 1. So 0 is not possible. Now what if we start from 1? So at 1 we'll see we have the gas available as 2 and we have minus, means we have required 4 cost. Okay, so this means 2 minus 4, which is again minus 2. So this one is also not possible. Okay, let's see if the 2 can be the starting index. So for 2 we see the cost, means the gas has 3 and the cost required to go to next is 5. So 3 minus 5 equals to minus 2. So again this is also not possible. So starting at 2 is also not possible. Now if we start at 3, we have the gas available as 4 and cost required is 3. Cost required is 1. So 4 minus 1 equals to 3. Hence we will have 3 extra gas to reach to 4. Okay, now we are at 4th index. So we have 3 extra. In this we have 5 gas available and required is 2. So it will become 3. New gas will become 3 plus 5 minus 2. Okay, so it will become 6. So now we have reached 4th gas station with available gas of 6. Now to go to the next gas station, to this we have, means from 4 we have now reached this 0th, means from this we have reached 0th. So at 0 we have this 6 extra gas. So 6 plus, now as we can see the gas available here is 1 and the cost is 3. So it will be 1 minus 3. This is simply 6 minus 2 equals to 4. So we reach gas station 1 with extra gas as 4. Now what do we see? At gas station 1 we have 2 available gas and 4 required. That means 4 plus 2 minus 4 equals to 2. Okay, so as at gas station 1 we means left with an extra gas of 2. So we reached gas station 2 with an extra gas of 2. Now at gas station 2 what do we have? We have the gas available as 3 and the required gas is 5. So that means 2 plus 3 minus 5 equals to 0. So now we have reached this 3th index, 3th gas station again, and hence we are able to do this without making our current gas as negative. Hence 3 can be our starting point to move in a means clockwise direction to complete path, means reach the starting index again. So hence the output here was 3. Let's say if we wanted to start from the 4th index, then as you can see like that may also be possible, because for example here we have 5 minus 2, so we'll have 3 extra gas. Then when we reach here we'll means give two gas back, so we'll have one gas remaining, and then if we reach this, it will 1 minus 2, which will be minus 1. So then we will see like starting at 4 is also not possible. Hence the only solution here is the index 3. So this is what the output here was. Let's see a different input. So we have the gas 234 and cost 343. So we have three gas stations 0, 1, 2. Now we need to see whether we are able to like suppose we pick 0 as the starting index. So we see 2 minus 3 is minus 1. 2 minus 3 equals to minus 1. So this is not possible. We start at 1. So we again see 3 minus 4 equals to minus 1. So we will not be able to reach the next station. Again for 2 as the starting point, we see 4 minus 3 equals to 1. So 4 minus 3 equals to 1. Hence we are able to reach, means from second index we are able to reach 0th station. Now at 0 we have 2 minus 3 equals to minus 1. So 1 plus 2 minus 3 equals to 0. So hence we are able to reach the first index with what? 0 gas. Now at first what do we have? We have 3 minus 4. So 0 plus 3 minus 4, which again becomes negative. Hence we did not reach this point back again with a positive gas. Hence 1 cannot also be a starting point. Well, means 2 can also not be a starting point because we started from 2 here. Okay, so as you can see, none of the means the starting indexes satisfies the condition. Hence in this case the output here is minus 1. And one thing we can observe here is we see like the total amount of available gases here was 2 plus 3 5 plus 4 9, and the total amount of available means the required cost was 3 plus 4 7 3 10. So the cost, total required cost was 10 and only 9 gas are available. So in if like sum of gas minus sum of cost is less than 0, that means like it will never be possible to like start from an index and reach it back. So we can simply like return minus 1 in this case. Okay, so this is one of the observations that we can make. Now how do we like solve this problem? So we saw like we can do it in a brute force manner, just how we dry ran the examples here. So for each index, keeping each index as a starting point, we can see like whether we are able to reach back that index in with positive form without encountering any negative gas or not. So what do we do? We move a loop for I from 0 till n minus 1, means which will be the starting index, the starting indexes. Now we'll move n steps, means one step, then two step, then three step, and suppose it array ends, then fourth step will be here, then fifth step, then sixth step, and so on. Okay, so we move a loop for j for how many steps? From 0 till n steps. Okay, 0 till n minus 1 means first index will be going to I plus j. So I plus 0, then I plus 1, then I plus 2, means these are the stations at which we will have the gases available and the cost required. Okay, so we'll do this till I plus n minus 1. So these many stations we need to go, such that means after this I plus n will be the ith index only. Okay, so hence we start means iterate through all the possibilities of the starting index and then try to move through all the possible gas stations, and at each step what we'll do, we'll update our like current tank plus equals to what, the gas that we have at that current tank, gas of j, and minus the cost required. Okay, and what we'll do, we means this suppose this is k, because this k will be simply I plus j, and as you can know like this I plus j, suppose it was 2 and it was 3, so means if we want to move 2 steps forward, so 2 plus 2 will give 4, but this index does not exist. So to represent this 4 as 0 here, we need to take it modulo n. So n here was 4 because 0 1 2 3 has 4, so percent 4 will give us 0. So this will point to 0th index. Hence we need to find the I plus jth index with mod n. So this will represent the indices in a circular fashion. Okay, so at each step we will find this, and if at any point the current tank becomes negative, then we simply know that this is not possible, since we break from this loop. Okay, and if we like iterate through all the possibilities and then encounter no case of becoming less than 0, so we can maintain a flag of bool possible, will maintain a flag of boost possible, which will initially be false. And if at any steps we are able to like, we did not make this true, means initially make it as true, and if we are breaking it, this means this possible will become false. Okay. Now if at any step we are not able to make this possible as false, that means if the possible still remains true, then this ith index was true and we can simply return this ith index. So this is the case of the, means we will start for each possibilities of the starting indexes and move through all possible n minus n 1 steps to reach back the I in a circular fashion. And if we are able to satisfy the condition of the current tag never becomes negative, then we'll be simply breaking the loop. So this is the case of like the brute force approach. And as we can see, like since we are iterating through all the possibilities of start indexes and this j will go to n, so this will be of the order of n into n, which is like n square. And if you try to analyze the constraints here are given as n can go up to 1e5. So hence this approach will go till 1e10, and which will obviously give us TLE here. Okay, so let's see the means the clear code once, so that we can get the approach in our mind. So this I we move for all possible starting indexes. Now the current gas that we have initially is 0, and we make this bool possible variable to see whether, means it is possible to reach back this I starting from I. Now we iterate through j for all possible movements from I. So I plus 0 will represent the I plus 0, means we are moving, means utilizing the gas station at the ith index. Then I plus 1 means we will be utilizing the gas at I plus 1th index. So this is what we will do till we are able to reach I plus n minus 1th index. And in this fashion, at each step we will increase our current gas count with the gas required at that index, and then decrease the cost. And if at any step the current gas becomes less than 0, then that means it is not possible to like reach back the ith index starting from I. Hence we will be making the possible as false and will simply break from the loop. And if at any, means if after iterating through the entire array, if this possible still remains true, then that means we are able to reach back I starting from I, and hence we will simply return I. And if our, means if we didn't return I at any steps, then in the end we will simply return -1. That means that sum of cost, means sum of gas minus sum of cost required was negative. So this will be denoting this. So hence in this case we will be simply returning -1. So this was like the brute force approach to solve this problem in the order of n square complexity. And as we can see, like since it can go up till 1e10, and it will give us TLE obviously. So we need to think of some optimization of like the check that we are doing internally in big of n. We need to means optimize this. So how we'll be optimizing this approach is the problem at hand here. So what we'll do here, let's try to analyze like how can we means what the current gas, if it becomes negative at any point, what it is representing. So if we like, let's take the example low. So suppose like we started at a index, means started at gas station A, and when we reached the gas station B, the tank from A to B becomes less than 0. Means it started at tank A, started at station A, and when we reached B, our tank, means tank of AB denotes the amount of gas required minus the cost, will becomes less than 0. So this means that it was the first station, means B is the first station at which the tank became less than 0. So this means like if we have any station K lying between means A to B, then that means like A to K, tank of A to K was greater than equals to 0. Means we did not encounter any condition in between such that the gas station means the amount of gas that we had became negative. And now we need to reach B. Okay, and as soon as we reached B, at B exact point we had the tank become less than 0. So what observations can we make here? So if this means that A cannot be the starting point, because if we started at A, then we got a point at which our tank's value became negative. So hence this A cannot be the starting point. So now we need to see how will be like if we get a condition where means a index cannot be the starting point. So what will be the next optimal value to start from? Whether it is some k inside, or whether it is b, or whether it is some index like just b, means suppose b plus 1. Okay. So what will be the most optimal way of moving this starting index for the checking? Means once we have checked from a to b, means is it redundant to like check for case in between, means gas stations which are lying between a and b, or we need to look for newer indexes which are lying beyond b? So let's try to analyze. So suppose we, means a was not possible, suppose we started at tank k. Okay, so that means tank, we need to find the value of tank from, if we started at this kth index which lies between a and b. So what we have is, initially we have the tank of AB, and it will be simply, if we, means it will be the sum of tank from A to k minus 1, means tank from A to k minus 1 plus the tank from k to b, right? These are the values. Now we know like this value is negative, right? And we know that at, means all stations which lie between these two values, these will all be non-negative, because B was the first station at which the tank became negative. So this is what, this is greater than equals to 0. So we need to see what will this represent. So tank of KB equals to tank of AB minus tank of A comma K minus 1. Now we know like this value is negative. Okay, suppose it is minus 4. And we know like this value is positive. Suppose it is 8. So we know like here we are subtracting a positive value from this negative number. So this means like this overall value will become more negative, right? Since what did we observe? We observe like if we have a station starting index A and we at exactly B, we find out that means it becomes negative, the tank value becomes negative, then that means we cannot pick any starting index which lies between these A to B, because obviously the tank between them, means the amount of gas required between them and subtracting the cost, will be negative. Since in this what we can derive here is like if we start at a 0th index and at suppose at index I we encounter, suppose we start at the ith index and at index j we encounter that from I to j we got the tank as negative. So hence we need to move this starting point to, means j plus 1, because obviously if we take any value which lies, means between I and j, then it is simply not possible, because it will be further more negative. As we can see, like tank of k comma b was the overall like tank of I to j which was negative, and tank of I to suppose k minus 1, and as we can know like all the middle values will be obviously greater than equals to 0. So this value will become more negative. Okay, so hence we need to update our starting point with j plus 1. So maybe if we are updating this starting point by jumping between indices, so in this manner maybe we'll be able to, means get rid of this second loop that we are using inside, right? So let's try to like let's try to convert it into code, like how we'll be trying to convert it, the same observations that we made, into code. So what do we have? Suppose we initially have the starting index, we are starting at 0th index. Okay, so the starting index initially is 0, and the current tank, means the current gas that we have, is also 0. Now what we'll do, we'll move from I equals to 0 till n. Okay, now what do we see? We see like the current tank will be increased by what? It will be the gas available minus the cost. Okay, the current tank will be increased by this value. Now if at any point it becomes that the current tank is less than 0, then that means we need to update our start index to some value. Okay, and that some value will be simply I plus 1. We need to update our start index with I plus 1. Okay, and we'll make our current tank as 0, so that from I plus 1 we do not have any previous gas available, because we are starting at the I plus 1 index. Okay, so this is what we'll do. And in the end we also need to check like if the overall like sum of gas minus sum of cost required is negative or not. If it is negative, then this start index will means even if it is updated, it will simply be not be possible, right? So we need to like maintain a diff like total tank, and we like at each step we'll update this total tank with the same difference. Okay, gas of I minus cost of I. So even if like at the end we'll see like if this total tank is less than 0. If it is less than 0, then we'll simply return minus 1, because there will be no possible starting points for start index. And then if this condition is not true, then that means whatever value the start index will be storing, that will be the correct output. So we will simply return start index. As you can see here, we are just taking the help of means we avoided the inner loop just by means skipping this means jumping this start index from like I to j. For I to j we jumped this to j plus 1, and hence this will be like the most optimal approach of the order of n complexity for this problem. So let's see the code once to get means the clarity about the solution. So we maintain 3 variables. This will denote the overall sum of gas required minus overall cost required. This will denote the current tank, and this will be the initially the starting index is 0. Now what do we do? At the current step, we increase our total tank as well as the current tank by the gain that we have, gas of I minus cost of I. Now if current tanks become 0, less than 0, that means we need to skip to j plus 1. So simply make the start index as I plus 1 and mark the current tank as 0. And if the overall means total tank is less than 0, then that means even if it is storing some value, that will not be feasible, because it will not be possible. So we'll simply return minus 1. And if it is not, then we know that a unique means if there exists a solution, it is guaranteed to be unique. So if it is not minus 1, that means there will exist a solution, and that result will be being stored in this start index. So means we will simply return the start index. This will be the big of n approach for this problem. Let's try to see the code as well, so that we get the clarity. So this is the same code that we did of big of n approach, and as you can see, like it runs in 4ms, which is means pretty fine, because n can go up to 1e4. So I hope you got the intuition of how we means first tried for all the brute possible ways, and then tried to get rid of the inner loop that we are heading. Then we try to see like how we will be handling. So we try to derive it using generalized cases, like as soon as b is the first point where tank becomes negative, if we started at a, and then we saw like if it became negative at b, then it will never be positive for any values of starting index between a and b. That it will be more negative. We will start at any point which lies between a and b, and then we did the derivation and we find out the observations, and as soon as we did, then we simply tried to convert this logic that we got into code, and this will be the overall logic for this problem. So I hope you are able to like grasp all the approaches discussed, and if you did, make sure to like, and if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.